Manisekharan. Let me introduce about him. So first of all, we are delighted to welcome Mr. Ashok Kumar Manisekharan, a distinguished entrepreneur, educator, and technology innovator as our resource person for this FDP. Mr. Ashok Kumar is the founder and director of Priya Labs and Phonobots Paper Robotics Private Limited, ventures that reflect his passion for bridging technology and education. With over a decade of experience in training, development, and research, he has made remarkable contributions in the fields of augmented reality, virtual reality, digital twin, robotics, and artificial intelligence. An accomplished educator and curriculum developer, Mr. Ashok Kumar has conducted more than 80 workshops and training programs across India, focusing on skill development, innovation, and emerging technologies. His initiatives have empowered college students, professionals, and young learners alike to embrace hands-on learning through technology. As an Unreal authorized instructor partner for Epic Games and Smart India Hackathon Evaluator, he continues to guide and inspire the next generation of innovators. His projects in AR and VR applications, IoT integration, and digital twin simulations stand as a testament to his innovative spirit and technical expertise. We are truly honored to have Mr. Ashok Kumar Manisekharan with us today. His journey as an entrepreneur and educator continues to inspire many, and his presence will undoubtedly motivate our participants to think creatively, innovate boldly, and pursue excellence. Welcome you, sir.
Thank you, ma'am. Thank you so much. Thanks for the introduction. Hope my voice is audible to everyone.
Yes, sir, audible.
Yes, sir, audible.
So shall we start the session, ma'am? Like
Yes,
Punita, ma'am?
Audible. Voice is not clear, sir.
It's clear, ma'am.
Is my voice audible now?
Yes,
Yes, ma'am.
Yes, sir. Yes, sir. Now
audible.
okay. Yes, sir.
Okay. So shall we start the session? Like
Yes, sir. We can start with the session.
Yes, sir.
okay. So are you going to share my presentation or I will share my presentation? Like I already sent the link to sir.
Sir, if you are comfortable, you can share. Otherwise, we will share, sir. You share.
Okay, sir.
If there is any difficulties, we will share.
No, sir. I will share then.
Yeah. Please carry on.
I hope my screen is visible to everyone.
Yes, sir.
Yes, sir.
Yes, sir. Visible, sir.
So first of all, I feel so happy to interact with so many faculties. I am seeing like we have so many participants. So really seeing the participant list itself making me more encouraging me like like the warm evening. I wanted to interact with all these faculties. So really thanks for the organizers for making this much big crowd. And then fine, I think I have seen the entire Atal FDP program is purely based on the ML based robots thing. And then the today's session we are just going to start work with start discuss about the design of ML based robots. I think since since all the people are faculties and then all the faculties are from the different disciplines. I think so. Am I right?
Yes, correct, sir.
Yes. Okay. Fine. So before we just focus on how to design ML based robots, we have to first have I'm not sure like how many of you having the very good idea about the robots, autonomous systems, and then the traditional way of robot, AI powered robot, and then what is the need of ML robots, what are all the things we have to cover. We have so many things actually want to discuss on design of ML based robots. So let's start from the very basic thing, so that slowly we will just get enter into the need of and then how we have to design ML based robots. So automation versus robots. So basically, can anyone, let's make a little interactive session. It will be, because if I only speak means it will get bore. Uh, Automation and then robot. These words are not new to us. So I have added a small scenario over here. Just read out the scenario and then can anyone tell, like, to do this operation, do we need to go for automation or we need to use robots? I repeat, where I have added a small scenario over there, which means a system sprays paint on thousands of cars every day. The pattern and timing never change. So to implement this, for this, do we need automation or we need robots?
Automation, sir.
Automation. Fine. Any other answer?
Sir, automation, sir.
Automation. Okay, thank you so much. Then consider this scenario.
Robot, it is correct.
Sir, here we need a sensor movement, sir. So hence robot would be
Robot.
optimal. Sir.
Robots, sir.
Okay, fine. Thank you.
Robots.
Thanks for the response. Yeah. Then for this,
Robot, sir.
okay. So can you tell, I have shown you three scenarios, and then for first scenario, you told like some people told it's automation we required. For the other two, you guys told like we need the robots. So the in both, which means in scenario 2 and scenario 3, all those robots are the automated robots.
Yes, sir.
In that case, can you justify like whatever the robots we are using in the real world, is it the automated one? I repeat my question. Whatever the robot we are using in the real world, is it automated one? Does a robot require the automation?
Yes.
Yes, sir.
Many things.
Yes.
Yes, sir.
Yes.
Yes. So of course, so automation, like most of the robots, not most of the robots, all the robots basically have this automation. So if we want to automate something, where the automation is required, in which situation we need the automation?
Whenever the task is repetitive and monotonous, automation would be optimal, sir. Whereas in the case of robots, the task may be repeated, but there is a possibility the robot itself can judge it. If there is any minor anomaly, it can also withstand that anomaly, sir. At that time, robots can.
Great, great. So that we must go with the automation when we are going to design the robots.
Yes.
Then, what is the traditional robot? And then can you tell some difference of traditional versus ML based robots? I have given the scenario over here. Just read out the scenario and then can you guys tell me like whether this kind of robots is traditional robots or ML based robot? And then do you know the difference of like what is traditional robot? Can anyone tell the example of traditional robots first?
Traditional robots, in my sense, doesn't require any additional learning, sir. Whatever it has been designed for, it does its purpose. Whereas machine learning robots can evolve. There is a possibility they can learn from the day-to-day input. Sir.
In that case, traditional robots also have some kind of learning content with it?
No, sir. Since based on the present scenario, since all the object shapes and positions are constant, there is no possibility for new entry. So traditional robots most optimal in this implementation. When the object shapes and positions are not predictable, there is a possibility of change in coordinates or in various other things. Machine learning based robot might be up.
Okay, I think got muted. I think so. Okay, fine. So as Sas said, traditional robots basically work with, it doesn't have any kind of learning content. It will actually work on if-then principles. Like all the robots have the sensors where it sends something in the environment where it will react for the environment happenings. So this we call it as a traditional robots, and then ML robots, as Sas said, like the robots have a ability to learn something. So where the ML comes in. Anyway, we are just going to discuss in a little briefer way. So since you guys are having the very clear idea of what is traditional and then what is ML robots, based on this scenario, can you tell for this particular scenario, we have to go for traditional or ML based robot?
We have to go for ML based robots.
Is it so?
Yes, sir. Because object detection, path planning techniques, these are majorly focusing on the ML based robots. Whereas if we take about the traditional robots, just the position and orientation, if we are feeding into the robot, that is going to be perform the manipulator operations.
Nice. Can you go for the this one?
ML based robots are because it has to detect emotions and it has to assess the scenario and respond differently based on each and every tone. The questions might not be similar. There is a possibility of similar question as well as dissimilar questions. And various frequencies will be there because all students will not be having the same amplitude in
Same
their
kind of,
speech.
yeah. Speech. Yeah. This one?
Yes,
For this scenario?
burgers in the fast food chain. Sir, here traditional robots will be suitable, sir, because making the burger, even though it may be different burgers, the preparation scenario is constant. So traditional robots will be suitable, sir.
Nice. In that case, if I want to convert this traditional robot into the ML based robot to perform the same operation. So is it okay if I convert the traditional robot into ML based robot for this particular scenario?
I think it might not be required, sir, because when a traditional robot is working fine, why we should go for this machine learning based additional investment cost, sir?
So we no need to go for the ML based robot on this scenario, right?
Yes, sir.
In the previous case, like it picks up identical objects and places them into boxes using fixed coordinates, right?
Yes, sir.
Huh. And then I'm not sure. Some sir told we need the ML based robot here. Is it so?
No, sir. Traditional robots are fine, sir.
Okay. So I think I have given 3 scenarios. Okay, not okay. So in these 3 scenarios, the robot listens to the students' questions and answers actually require the ML based robot. So that, as you all know, can you answer for my question, like AI and ML both are same or different or what it is? I repeat, can anyone answer for my question? AA and then ML, both are same, or AA is a part of ML or ML is part of AA?
ML is part of AI.
Yeah.
ML is part of AA. How we need that?
I beg your pardon?
How we need ML?
We need ML through a set of algorithms.
How we need? How we need? What is the purpose of introducing ML agents?
For analysis purposes.
The purpose is to make the machine work as a human, understand as a human, and we need to understand the machine as well in return.
So ML is a generalized concept that we require to make a system to be act smart, or the ML is purely for the robots.
No,
I
it
repeat me.
is a general methodology which
Mhm.
enables the machines
Mhm.
to act in a way a human thinks, acts, and to synchronize it for doing multiple works.
Fine.
Am I correct, sir?
Yes, yes, of course, yes. Thanks for
Thank
the
you so
answer.
much. Can I mute myself now?
Yeah,
Oh, all right.
fine. Uh, okay. I think if we talk about the ML, basically people will talk about three types of learning, three types of ML. Can anyone list out the three types of ML? The
Supervised
basic three
learning,
types of ML.
unsupervised learning, reinforcement learning, sir.
Yeah, supervised, unsupervised, and then reinforcement learning. By seeing these GIF images, can you tell which one is act like a supervised learned robot, which one is the reinforcement, which one is the unsupervised?
Middle one is reinforcement,
Mm-hmm.
and the rabbit one is supervised.
Mm-hmm.
And this, the one who is solving, I think it is placing something in the rack,
It is not
unsupervised.
placing, it is trying to pick something.
Okay, sorry, I'm so sorry.
It's okay.
Okay, yeah, that is, as per my opinion, unsupervised.
Can anyone differentiate supervised, unsupervised, and then reinforcement with a very small example? Shall I go with supervised learning? Am I audible?
Supervised learning, we know what we have to do. Unsupervised learning, we don't know, sir,
Yes.
what we are going to do. Reinforcement learning, it will be repeat both a combination. Whether we know, we don't know, we can able to process.
Mm-hmm.
Supervised learning data set is available, sir.
Mm-hmm.
Based on the data set, we can train the
label will be there in data set.
Yeah. Label will be there. Thank you, ma'am.
Unsupervised can be, sir, the customer segmentation means whatever we see on social media, any purchase or things like that. Few will give you feedback, few will not, few will just put emojis or a dot, things like that.
Reinforcement learning.
Feedback based learning.
Feedback learning.
Yes, great. Thank you.
Now,
Now you guys told me everything correctly, like where maybe I will summarize like soon. Like supervised learning, where we have the labeled data set, based on that it will work, the machine will work. Where unsupervised learning, input should be there, output it will detect. Where in the reinforcement learning, it will do everything on the trial and error methodology based on feedback, whatever it is going to get, based on it will train by itself. I think whatever you told, I'm just repeating the same thing. In that case, can you see the images once again, and then can you tell which one suits for which type of learning? I already got the answer, but it's not correct. A small thing was missed. So that's why I'm asking one more time. Just see all the GIF images and then tell which image suits for which type of learning. Can anyone tell the first one? The
First one is label is known, sir, so that it is supervised learning.
Supervised learning.
Okay.
That
Second one?
last one is that object don't know, but that machine is doing unsupervised learning. That middle one is reinforcement learning, I think.
First one is correct, second one is correct, but the last one is not correct.
Why?
Yes, sir.
Can you see that robot? We have two toys over there.
Yes.
Right? Dog and then rabbit.
Yes.
The robot movement is actually happening like it's moving based on dog or based on rabbit.
Based on rabbits.
So it's already labeled, right?
Yes, labeled. Yes.
Yes,
That's
sir.
why it is following only the rabbit, not dog.
Dog. Yes, sir. Yes, sir.
Actually, we didn't add any unsupervised learning image over here. So the first and third is actually the supervised learning, and then where the middle one is the reinforcement learning.
How all these are useful for the rural areas?
Come again?
How are all these robots are useful for rural development of India?
Yeah.
Are you listening me? Hello?
I'm not getting, your voice is not clear, sir. Can you come again, please?
How all these robots will be helpful for the development of rural India?
Okay, you are asking how these robots are going to help for the country development. Am I right?
Yes, I'm talking about rural development, rural India development.
Rural India development.
Yes.
For the rural India development, obviously, if we want to make these robots to work on rural places, many things have to be changed on rural places first of all, sir.
Yes. So because we are focusing how we can develop rural India. So
In
how
that
these
case, we
robots?
have to, that's why we can like the design of ML robots based on, if we are not focusing on use cases like for the city sites, we can focus on rural side, and then whatever the infrastructure available on the rural side, we can design our robots where it can be suitable for the rural areas.
Yes. So we should design these robots based on our rural requirement, so that our rural India will be able to utilize all these new upcoming technologies.
Yes, of course, yes, sir.
Yes, that's the objective of the app TV. And yes. Thank you.
Okay. Yeah. Yes, can you see this scenario and then can tell like what type of learning we have to use it?
This ML robot.
Of course, it's ML robot only. What type of learning?
Supervised
This is
learning.
used for
Supervised learning, sir.
This is supervised learning. Thank you.
Yeah,
And then
supervised
this
learning.
one? This one? This is also supervised learning because
Yes,
it's already
supervised.
labeled.
Yes.
This one?
Unsupervised.
Unsupervised.
Not supervised.
Unsupervised.
Yes. This one?
This is reward and then reinforcement. Because
Reinforcement.
reward element.
So this is reinforcement learning. So here, basically, if we want to design an ML based robot, we have to focus on three different layers. The first one is the perception layer, second one is the decision layer, third one is the action layer. So the perception layer, where we have to focus on what type of, how the machine should be, and then what type of components that we are going to use to understand the environment. Whether are we going to use the sensors, or for the better understanding of the environment, are we going to use the camera of in the robot? So all those things have to be designed first, and then have to be designed based on the use cases, where we have to first focus on the perception. Then the second one is the decision layer. So whatever the perception layer is capturing the data from an environment, based on the data the robot is acquiring, where it have to be take decision what action the robot have to be done. So where after this particular decision only, the robot triggers all the actuators connected with the robot to be triggered, where the robot start do actions for the decision that it wanted to react for the happenings on the environment. So we have to be very very careful on designing our ML based robot, especially on the hardware part I'm talking about initially. Because if you are fail on the hardware side, definitely the understanding of the environment will get fail. So it will not help the machines or the robots to take the proper decisions. And as well as the perception layer is just focusing on the identifying the components, assembling the components, where the decision layer have very strong algorithmic nature, where it have to use the proper algorithms to take the proper decision for the happenings going to happen on the environment. So if the perception and then decision layer is too strong, then we can make the actuators to work based on the decision whatever the robots design. Is that clear, the main three important things? Like the perception, decision, and then action layer?
Yes, sir.
Yes. So designing an ML based robot, I have listed some 6 steps, where the first thing we have to identify the purpose. So what is the main purpose of building that robot? Where we are going to use it? What will be the environment? Where it is just going to work? What are all the actions it is just going to do? So based on that, if you identify the purpose, so it will be easy for you to identify the components, and as well as assembling everything, where it comes under the perception layer. You can see the define purpose, select sensor, choose controller. Can anyone tell me like how many of you worked with the real robots? Just I wanted to know. I'm just curious about it. Have anyone worked with any kind of robot? Have anyone built any robots? Maybe have you guided any students team to do any kind of to help them to make the robots?
Yes, sir. I updated it.
Uh,
Yes.
may I know in simple words like what robot it is?
A sweeper robo and
Sweeper
drainage
robot.
robo. Yeah, sweeper
Okay.
robo and drainage robo.
Okay. So it will just it will work kind of traditional robot. Am I right? Or
Yes, sir.
you
Exactly.
implemented ML?
Yes, exactly. The traditional before the emerging of ML itself, we have planned like and we have designed a traditional robots only.
Okay, fine.
Yeah.
May I know what microcontroller you have used? Do you remember that, sir?
Yes, ordinary Atmal, sir. Atmal microphone.
Okay, Atmal means then automatically it will be kind of Arduino board.
Yeah, yes, exactly.
Yeah, because it uses the
During the
Atmal.
time of 2017 and 19.
Okay, okay, nice.
Before
So
the emerging of ML itself.
okay, fine. So that basically, if you want to see, and then where before just go into these things, I just wanted to have a clear idea of. Can anyone tell what is robot, what is robotics? Both are same or both are different?
Both are different.
Then what is robotics?
Robotics is the studying of science and technology.
about the robot.
Yeah. So where it will help us to uh, make like it will help us how to make a robot to
Robot.
work on an efficient way, so that even in the robotics itself we have the three important phases like designing a robot and as well as the assembling and circuiting the robot and then writing the logics for the robot. This is the three important layers that is available on building the robot, but we are talking about building an ML based robot where the designing and then the assembling and circuiting, everything comes under the perception layer. I told three different layers available on the ML based robot designs. So this here defining purpose and then selecting the sensors, choosing the microcontrollers, assembling everything comes under the perception layer. Then collect and train the data where it will comes under the decision layer, and as well as deploy model to hardware. It will comes under actually the deploy model to hardware will comes under the action, but collect and train data where we have to collect the real world environment, and then we have to do train. We have to analyze the data whatever is capturing from the real world, and then we have to train the robot to take the decision on the happenings. So here the collect and train data, as we have a very basic idea of what the ML do. Let's consider we are having some kind of robot. It want to be act smart as similar to the humans. Obviously we have to introduce ML to it. So collecting and training data, this should be happen on spot, or the robot should be trained before itself. Have you got my point? I'm just asking a question. To make a ML based robot, do we want to train the robot priorly, or we have to design a robot to act on spot?
We have to train the robot compulsory.
So are we not able to make a ML based robot to be act on spot to
See,
get
on
trained?
spot, on spot, if you are clearer about the this thing, what type of application you are building, and you know what type of information you are going to grab to train the robot, then you can deploy. It's either maybe.
Okay, but I have written our collect and train the data. In that case, I collected already so many data and then I have trained. So where this model is going to, as you all know, if we collect and then if we train the data, we will get the trained model. Can you tell like the model should be available where? It should be available inside the robot memory, or it should be available on cloud?
Should be available on cloud if you are having earlier information, so that I can deploy it on the robot to train it.
In that case, do we need the internet accessibility for the robots?
Yeah, definitely.
In that case, all the internet powered robot uses the IoT.
Yes.
So here,
Maybe if you are replacing IoT, if you are having vast amount of data, because when we develop any raw system, it will have limited memory. Like if you take any controller board, all those things. If we take if we are having the close to the system, I can run it on Wi-Fi or radio, infrared, like that. Communication transfer. If it is far away, if I want to deploy far away, I need the Internet of Things. It all depends upon how much area where I am deploying the robot.
Okay, fine. Thank you, sir. Thanks for that answer. So in that case, what is the advantage of having the trained model on cloud? What is the advantage of having the trained model on cloud instead of having it on the device itself?
It will be beneficial to test and validation will be very easy for us, and we can know what changes we can make when we are applying that robot.
Yes. Do we need a very big cloud infrastructure to handle the trained model?
It depends upon application where we want to this thing.
So, thanks, sir. Thanks for that answer. So that all the ML based robots, the main thing, if your perception layer is over, we have to go for the decision logic where we have to use the model, and then based on that, we have to write the logics to make the robot to take decision. Once the decision is made, then the microcontroller triggers the actuators. Actuators means like whatever the motors or servo motors, whatever is connected with the robots. Basically all the robots work, it has so many motors. Because most of the robots are actually movable robots, and then it has so many motors, so that motors we have to call it as a actuators. Not only motors like LEDs or the speakers, sound systems, whatever we are having on the robot, everything is the actuators, where it will only get trigger if something is happening on the environment, where the controller controls it. So that the decision logic. So based on the use case, we have so many algorithms available in the machine learning. So we have to choose what type of algorithm we have to use to make the robot to take decisions properly. So, and then as we discussed a few minutes back, we have to decide the model should be available on cloud, or it should be available on the device itself. It's always, if we have the trained model on the cloud, it will be very much helpful for us, because if we want to do any update, we have to, maybe our robot may be available in wherever in the world, but if it is going to work only based on the model what we trained, it's available in the cloud. If you do any update based on that, automatically the robot will start take the decisions based on the environment happenings. So it's always suggestible to have the trained model on the cloud. But as this FDP is purely focused on building the ML robots for rural development, since many of the rural places not yet that much sufficient internet available on the rural places, in that case, how can you justify of how can you justify of having the ML robots on the rural places? Hope my question is clear.
So there can be other networking methods like Bluetooth for short range, maybe some other alternative apart from
Sir,
internet.
if you are going for the Bluetooth, anyway, our data is not at all going to available on very nearest places. Since we are using our ML model in the cloud, in what way Bluetooth is going to help us to fetch the to access the cloud data?
We
And
can have some prior trained models. Previously trained models can be used in the rural areas to do the work.
Or can we use RF waves, radio frequency waves?
Even if you are using the RF, it's not the range is little high compared to Bluetooth now. But comparatively, if you compare with the internet, the range is less only now.
Or at that phase, we can't use if Internet of Things means we have to develop a smart with information limited directly to deploy the model. It doesn't work on Internet of Things.
In
I
that
have to
case,
develop.
okay.
Only a confined application where I can tell that robot can do this type of application, automate the thing.
So it is a tradition, not traditional, like it's a, if you are doing like that, okay, it will comes under the traditional robot only now, because there is no, the robot doesn't have the proper internet access, so it is just going to repeat the same process again and again and again. This is what the traditional robot is doing. Am I right?
Yes, sir. Yes, sir.
But
So
I think
without using the model, without using the internet, again we are doing the same thing on the rural area. So we are using only traditional robots now.
but we can have Android application because Android phones are nowadays buying anyone. I don't think so. Very limited sources where it is tribal on hilly regions, the network may not be seen good. But most of the places we have network now, mobile network.
Okay. We have a solution for this.
Okay.
Can you read it? Do we need Edge AI for ML robots? Can anyone have anyone come across on Edge AI before?
Yeah, this picks data and analyze data on the spot before sending to cloud. So
It's a end-on-end
at
solution.
the environment, at the sensor level.
Actually, it is not going to send anything to the internet and all. Basically, Edge AI is the new technology, new techniques. That is where the companies are started to deploy it on robots or machines, whatever it may be. The AI, the intelligent system is going to act on the edge of which means on the machine itself. For that, whatever the previous robots we are talking about, if we are having the ML model on the cloud, and then we have to go for the we have so many microcontrollers available in the market. Like once I told, we have Arduino, we have Raspberry Pi, we have the ESP8266, we have ESP32. So even for ESP8266, ESP32 itself, we have so many variations, where most commonly used microcontrollers for the IoT, and then ML based robots for the basic prototypes. The people are using the ESP8266 or ESP32 microcontrollers, right? But all these kind of microcontrollers doesn't have the ability to handle the data on spot, which means on the edge, where we have specialized microcontrollers where it will have a ability to handle, to collect the data, to do a basic training, and then to make the robot to act smartly based on the environment happenings without connect with the internet. Have you understood?
Very good.
Have anyone come across about NVIDIA's Edge AI solution? I think you guys know NVIDIA, right? NVIDIA company.
It is US based company.
Come again?
Is it US based company? NVIDIA.
NVIDIA,
Yes,
not
yes,
sure about it,
US
but
based. That's correct.
I think so. But most of us are using the NVIDIA graphic cards in our
Yes.
laptops, in our computers.
Yes.
So
But it is US based company.
Yeah, I know this company. This is also in education as well. I
yes,
got
Yes.
certain
Are
certificate from it.
you, sir, are you talking about Jetson Nano, like
of course, yes,
Jetson?
of course, yes. Jetson Nano, Jetson Orion.
Yeah, we have that models at our lab, which we train our
Great,
students.
great. Where we have the NVIDIA right now, NVIDIA is completely focusing on helping the people who is very much eager to build the robots. We need a very good computational power to make the robot to act smartly. Since the NVIDIA company is already working with the GPU, which means graphical process unit, where see, basically all the machines we have the CPU and GPU. CPU will help us for processing the less amount of data, but if you want to handle the large amount of data, the CPU will not help us. We will obviously go with the GPU. That's why mostly the graphics card the people are using to play the games, where the game data is too high. The CPU doesn't have the ability to handle it. That's why if we are playing any games on the normal system, where it will get hang or the computer completely slows down. But if we have the GPU, which means the graphics card on the system, or whenever if you are opening the game application, automatically the CPU is not at all going to handle anything. The GPU itself taking care of handling all kind of large amount of data. Since the NVIDIA company is handling has its own models, where they started to help the people who is going to build the robots. They are right now, they are maybe I can stop sharing and then I can open the NVIDIA website. So I can show some kind of processes available so that it will be helpful for you. You can do some kind of research. You can also purchase. You can also try to deploy on your ML based robots. Let me share my screen again. Right now, they are providing so many courses and as well as so many training tutorials to, if you want to really go with the edge AI solutions. I am sharing my screen now. Hope my screen is visible.
Yes, sir.
Yes, sir, it's visible.
You can see.
Yes, sir.
Yes, sir.
This is what once I told now, like NVIDIA Jetson. We have the so many Jetson models available. You can see. So everything is little costly. It's a kind of graphics card where we can simply use it on our robots, where it has a very good computational power to handle a large amount of data to do the on-spot data training, model training and all. So whenever you get time, kindly go and visit and then just explore this kind of this particular Jetson series are not only for building the robots. If you want to implement edge AI machines, even on computer, you are using some kind of application. So if you want to, for example, we are having yeah, sorry. So suppose if you are having a machine where it handles the visitors of our institution, where we don't know who is going to visit our institution, where the edge AI will help us, where once it once it captures, or once the machine captures the visitor, and then it will get trained by itself, and then it will record the data. If the same visitor coming for the next time, it will automatically detect who it is. So this is how the edge AI will help us to collect the on-spot data and as well as to handles it to train the machines on spot. So just go with edge AI is the most needed one while you are going to build the robots for the rural areas. That too, if there is no network, we do not require any network to make the robot to work. If you are having this edge AI solution, if we deploy it on the robots where it itself taking care of everything, just we
Very
have
good.
to write the logic of once the data comes, how the robot should handle it, which means how this controller should handle it, how it should get trained, how it should trigger the actuators. That logic we have to write.
This Jetson AGX where is very costly, no?
Yes, all the Jetson shares are costly. Maybe Jetson Nano we can purchase. It's
And what,
around some 10,000 or 12,000, I think so.
because it can be purchased by only government, no? Because there is cost of 899 USD. Jetson AGX there is.
Sir, for the basic level prototyping, basic level understanding, if you want to go for the Edge, you can go for the Jetson Nano.
Jetson Nano,
The
okay.
Jetson Nano
Because
we can
it,
buy, sir. No
No, it's
problem.
cheap. It's cheap. It's cheap. Yes, yes, you can buy. This is very cheap.
Yeah.
Jetson Nano we can easily purchase. It's around 12,000 only.
Yes, it's very cheap.
Yeah. Even with the Jetson Nano itself, we can do very good
Lot of
prototypes.
yeah.
Yeah. And then they itself provide more simulation softwares um, to test our robots basically. Let me share my presentation screen again. Yes. Hope my screen is visible. Yeah. So
Yes.
yes. So maybe we started with small basic things. I just wanted, I'm not sure, I don't know like how many of you worked with robots, how many of you worked with MLs, how many of you know the basic things about the ML. That's why I have added so many things on the beginning stage. But
Okay.
yeah, so but now as maybe since it's a webinar, I'm not able to cover so many things. Suppose if it might be some kind of hands-on workshop, I might be helpful to make easy for you to make a very base level ML based robot, so that where you may get understand how these ML robots will help us for the development of our country. So at last the conclusion. Sorry. Yes. So as we need machine learning, of course, we need a machine learning on robots where it will help the robots to think smart and then to act smart. And then not only sensors, we have to go with so many sensors, and then we must use the camera where it will be a eye for the robots, because the robots doesn't have the eyes. Where the
Yes.
camera will help us, where the computer vision comes in. Have you, I think you guys come across the computer vision, right?
Yes.
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 Yes, yes.
Yes, where the computer vision comes in, where we have to use the camera, where the machine will automatically detects and then understands the environment based on the camera feed. So where you must use the camera on your ML based robot, it will be very much helpful. The only thing you have to be focused on is the decision making. You have to decide what microcontroller you are going to use. If you are going to use very large amount of data, even though if you are having the model on the online, so where you can go with any kind of internet supported microcontrollers. We have so many microcontrollers where it support internet. Or if you don't want to connect with the internet, then obviously you have to go for the Edge AI. So Edge AI is the best solution for the intelligent robots to make the intelligent robot without connect with the internet. So that's all about my session, and I'm open to answer for all your questions. So if you have any questions, you can ask me, so that based on my knowledge and experience, I will able to explain the things.
Sir, I have one doubt.
Yes, sir.
If I want to path plan a mobile robot in a scenario, suppose, see, I am an education institution. I want to make as a service type of robot where I want to send the document from one department to another. Or if I want to make a notice, it has to go on its own to the classroom. All these things. So, which type of ML algorithm is best suitable other than Q learning algorithm?
Sir, actually, since it is just going to circulate the circulars and then give the notices to the classrooms, right?
Yes.
So the infrastructure and then the movement of the robot, it is just going to be a constant one, right?
A constant one, but see, I can't predict the movement of the persons who are in wandering into the veranda. So I want to make it use of a dynamic
Where you
environment.
in that case,
Mm.
obviously we have to go for the reinforcement learning,
Yeah.
or you can go for the LiDAR. You can add the LiDAR.
LiDAR we have done a lot of experiments on LiDAR using.
So the LiDAR will help you to make the robot to move without any collisions.
Yeah.
Okay. So
Actually,
for
I
that,
am.
we no need to go for the ML. For the
Yeah.
like, it's basically obstacle avoidance robot. That's it. Whatever the obstacle is coming in front, it will just avoid that, and then it will not get collide.
Okay.
Because it is just going to work on LiDAR data, right?
Yeah. One more doubt, sir. May I know the difference between the ROS and ROS2? What is the updates that in ROS2?
I didn't have experience on ROS, sir, but I have seen the
Okay.
article like we have ROS and ROS too, but still I didn't worked on it, so I'm not able to tell the actual difference of ROS and ROS too.
Okay, okay. Actually, I am the program coordinator of robotics automation at Vignan University. So
Oh, great, sir.
I have developed the course for the robotics and automation exclusively
Nice,
for
nice.
BTech. So I thought you may have an idea. Okay.
Okay, ROS I didn't work, sir. I just worked with one small ROS based robot some 4 to 5 years back. After that, I didn't worked on it.
Okay. Okay. So your this lab is situated at where, sir? Tamil Nadu based? Or,
Yes, Prylabs is located at Tamil Nadu. It's in Tiruvannamalai.
Oh, Tiruvannamalai. Okay. Okay. Thank you.
Thank you, sir.
Sir, one participant has question
Mhm.
in chat box.
Mhm.
Like, what is the difference between Raspberry Pi and Jetson?
See, Raspberry Pi is it doesn't have the GPU power to handle the large amount of data. Raspberry Pi is a small kind of computer. It has the better CPU power compared with the other microcontrollers. But the Jetson, the Edge AA, not Jetson is a kind of Edge AA processor. That's it. We have so many Edge AA processors available in the market, but all the Edge AA based processor have very good computational power. Am I answered for your question?
Yes, sir. Thank you, sir.
Yeah. Raspberry Pi is a kind of a tiny computer. That's it. It's comparatively too good with if you compare with all other microcontrollers, but it doesn't have the GPU power to do the model training, especially.
Okay. So participants, if you have any questions, so please post in chat.
Can you say some HGI processors which can be used for HGI processors, and what are the advantages of using that?
So, ma'am, that's why I told like right now all the HJA microcontroller costs are too high. Only this Jetson, but we have a ESP32 base level microcontroller, but it will not handle more data. But if you want to go with, I just forgot that series number. ESP32 microcontroller come with very basic level HAI solution. It cost around some 2000 rupees, I think so. That's it. The main usage of HAI on the machines is on spot data model training. We don't know what is going to happen on the environment. If we have the already trained model, if the model doesn't have that particular data set, if new thing is happening on the environment, the machine will not react for it. But if we implement the edge AI, whatever the new happenings are going to happen on the environment, it will automatically start train based on the real time data set, and then it will start think to do some actions.
Hello.
Hello, sir. Yes,
Ashok
sir.
Kumar Manishakran. Hello.
Yes, sir. Yes, sir. Yes, sir. You are
Are you
audible.
listening? I'm audible?
Yes, you are, sir. Please go
May I
ahead.
may I ask a question?
Yes, sir. Please.
Just because your presentation is very good, but I have two questions regarding reinforcement learning for agriculture. First question, what reinforcement learning technique? Hello?
Yes, sir. Go ahead.
Are you listening me?
Yes, I am.
What reinforcement learning technique would you use to train a robot to show seeds in a field with varying soil quality and seed types and why?
Can you come again the last statement, sir? To
What
train the
reinforcement learning technique would you use to train a robot to sow seeds in a field with varying soil quality and seed types and why? Hello?
Can you
Hello?
put it? Yes, sir. Yes, sir. You are
Are you
audible.
listening?
Can you put it on the chat box, sir? I think some other noises I am getting from some other
No,
participants.
I am speaking very loudly. What reinforcement learning technique would you use to train a robot to sow seeds in a field with varying soil quality and seed types and why?
What reinforcement learning technique we have to
Yes.
use to train the robot
Yes.
to see the seeds?
In the field with varying soil quality and seed types and why?
That last word I'm not getting, sir. I'm not understanding because
Yes, I am concerned with rural agriculture. So my
yeah.
question is, what reinforcement learning technique would you use to train a robot to show seeds in a field with varying soil quality and seed types and why?
Varying soil quality.
Yes.
Sir is asking about for different quality of soils, which type of seed has to be used. That's what sir you are asking.
Okay.
Yes.
You can use CNN or RNN, sir, recurrent neural network, or CNN, convolution neural network.
Neural network, CNN.
Yeah, CNN you can use.
CNN we can use.
Yeah.
Okay. My question, second question, how would you apply reinforcement learning to train an autonomous tractor robot to care for crops with different species and weather conditions? And what algorithm would you choose? Hello?
Yes, sir. Yes, sir.
Are you listening me?
Yes, sir. I'm listening, but I'm not able to get some words. That's what I'm.
Yes. How would you apply reinforcement learning to train an autonomous tractor robot to care for crops with different species and weather conditions and why and what algorithm would you choose?
You're talking about the autonomous tractor robots, right, sir?
Yes, sir. Auto.
So autonomous tractor robots for identify the species.
Yes, and weather condition.
With
So
what
what
condition?
algorithm would you choose?
For harvesting, sir?
Yes.
Sir, it all depends upon what factors you are choosing to give input to the robot.
Sir, actually here the algorithms that we have to decide based on the actual environment, like maybe some algorithms may suit for all conditions, but we are not supposed to tell only this particular algorithm will help us to get the actual solution. We have
Yes.
to go with multiple algorithms, maybe where the edge AI will help you.
Okay. Okay.
Because you may write a logic with different algorithms, and as
Okay.
well as you have to write the logic to take the decision of the robot what algorithm it have to be used.
Yes.
Because people may tell like this algorithm suits for this problem, this algorithm will suit for this problem, but if you go with some kind of scenario, that algorithm will not going to help.
Yes.
Where the machine itself has the ability to decide which algorithm that I have to use to solve this issue.
Yes.
Where you have to go with edge AI.
அதை போட வேண்டியதுதான் வேணா பெருசா இந்த கலர் போட மாட்டேன்
Hope I
Thank you very much.
answer your questions.
Thank you very much.
Thank you so much, sir.
Thank you, sir.
Thank you, sir. Thank you so much.
Thank you very much.
Thank you, sir. Thank you so much.
Okay, so now we have come to end of our session 3. We are really thankful to you, sir, for your time, effort, and enlightening presentation. We had a great interaction also. Thank you so much, sir.
Thank you so much for inviting to inviting for this session, ma'am. Actually, really, I enjoyed a lot with so many questions.
Me too.
And then
We too enjoyed a lot, sir. Really, it was very interactive, very great interaction we had. Thank you so much, sir.
thank you so much, ma'am. And then, dear faculties, I have added the QR code over here. Take a snap of it. It's a feedback. If you give the feedback of the session, it will be helpful for me to understand, and then I can. It will be helpful for forthcoming sessions as well.
Okay. Thank you very much.
Okay.
Thank you, sir.